Now, whichever exam board you study, there are certain experiments that you need to know about, perhaps maybe the internal resistance of a cell. And a way to kind of maybe think about these as you're planning your revision is to think about some of the following headings. First of all, you need to think about what equipment you're using and maybe a diagram of the apparatus. So for maybe measuring the internal resistance of a cell, you need some kind of meter that you're going to be recording things on. And it's often useful in your notes to maybe just jot down a diagram of the apparatus and how it's set up. Now, it doesn't have to be perfect, but it has to show the main things. So here I've got my cell with its effectively internal resistance here. I've got a voltmeter across it to measure the terminal PD, an ammeter in the circuit, and then I've got a variable resistor. So for me, that's all I need to remember. But then what measurements am I taking? Well, this is what you've got to think about. Sometimes they're straightforward, sometimes they're a bit more tricky. It might be in this case here, what you're doing is you change the resistance of that external part of the circuit, and then you record maybe the current in amps and the potential difference V in volts, okay? And you maybe take sort of 6 readings of each of these. You can then think about not only what measurements have you taken, but maybe some relevant equations. In this case, you've got the equation that says E is equal to V plus IR. So, it doesn't really matter what experiment you're doing. Think about how the equations that you know fit into that. We can also think about how this is rearranged to maybe make V is equal to minus RI plus E. And then how this maybe links to the equation that says Y is equal to MX plus C. Now, for most of the experiments that you're going to be doing, there's often a graph of data. This allows you to spot anomalies, and it allows you to calculate a gradient and maybe a y-intercept, which maybe have some meaning. In this case here, I've just got a sketch of what you'd get. So you get a graph that looks a bit like this. You plot V, the potential difference on this axis, and the current on this axis. And then if you think about y equals mx plus c, well, your y value is V. Your gradient m is equal to minus r, so it's minus the internal resistance. And then that means the intercept c up here is equal to the EMF of that cell, effectively what it would supply if there's actually no current going. Now, not only do you need to know about this kind of stuff for every experiment, you need to think about maybe some of the kind of the practicalities. Are there any risks? Are there any hazards? And what precautions should you take? This one here is a pretty straightforward example, but perhaps if you're maybe looking at diffraction gratings, you've got to think about the hazards from the laser light, perhaps if it gets in your eye, the risk which it might cause some temporary blindness, and then precautions that you might take, for example, not turning it on for too long or only shining it at a matte screen rather than a reflective surface. So if there's anything that you can think about to do with your safety, that's really important. Finally, on the sheet here, I've got sources of error. And again, some of them, there might not be too many errors. It might be this, you may have something heating up if it's left on for too long. So what are the errors and how can you reduce this? Is there a way that you can make your measurements better? Rather than just using an analog meter, you're maybe using a digital meter, for example. So this kind of format here, you need to think about for every kind of experiment, especially the ones that you do for your practical endorsement, but all the experiments that you do at A-level physics, if you think about them like this, that will help you really prepare, and therefore you can sort of go into the exam knowing that you know how to answer questions about those experiments. How do you set up the equipment? What measurements do you take? What kind of data can you plot and how can you use that to find out a physical constant? And then are there any hazards, and also how can you improve that experiment?